Hello students. So last day we start about the Vsepr theory, that is valence shell electron pair repulsion theory, and also sometimes it is called Vsepr theory. And this Vsepr theory or Vsepr theory predicts the shape of a molecule or ion on the basis of minimum electrostatic repulsion between the negatively charged electron in the valence shell of the central atom. And we also discuss about some structures, and actually according to Vsepr theory, the structures of a chemical compound depends on the steric number, that is if steric number equal to 2, the structure is linear. If steric number equal to 3, then it is trigonal planar. And if steric number equal to 4, it is tetrahedral. Similarly, for 5, if steric number equal to 5, then it is trigonal bipyramid. Similarly, for steric number 6, it is octahedral. For steric number 7, it is pentagonal bipyramid. And for steric number 8, it is square antiprism, but this square antiprism actually out of syllabus. So that is the relation between the structures and steric number. And actually steric number means number of lone pair electron plus number of bond pair electron. So the total number of electron pair equal to known as steric number. And we also discuss about some structures. So today we discuss from this trigonal bipyramid, because last day we discussed about linear, trigonal planar and tetrahedral structure, and today we discuss about steric number 5, 6 and 7. Okay, so what is the structures of water molecule? Here central atom equal to oxygen, and the valence electron of oxygen atom equal to 6, that is the electronic configuration of oxygen equal to 1s2, 2s2, 2p4. So this is the valence electron. So oxygen have 6 valence electron into their valence shell, and this 6 valence electron actually involve in sigma bonding with 2 hydrogen atoms. So one electron of oxygen atom involve sigma bond or produce sigma bond with one hydrogen atom, and another valence electron of oxygen atom also participate in the sigma bond with another hydrogen atom. And this remain 4 electron are known as lone pairs of electron, and they present 2 lone pairs. So number of bond pairs electron equal to 2, that is 2 sigma bond produced. So total bond pair electron equal to 2, and 1 pair means 2 electron, that is 2 bond pair means 4 electron, 1 electron for oxygen atom and 1 electron for hydrogen atom. Similarly, lone pair equal to 2, that means electron pair equal to 4, and this electron pair actually known as steric number. So if steric number equal to 4, then the structure of the oxygen atom is tetrahedral, but as they present 2 lone pair, so the structure looks like this, and it is actually V-shaped structure. This is lone pair, and actual shape of water molecule is V-shape. So what is the bond angle? When a molecule possesses 4 steric number, then actually the structure of this element known as tetrahedral, and for tetrahedral the bond angle is 109 degree 28 minute. But in case of water they are present 2 lone pair, and there present a lone pair repulsion force. Lone pair repulsion force. This lone pair repulsion actually repels this lone pair in this way, and they present far apart from each other. That's why they also create a repulsion force between this lone pair and bond pair, and it is known as lone pair bond pair repulsion force. Again, there also present a lone pair bond pair repulsion force, and due to this lone pair repulsion and lone pair bond pair repulsion, this oxygen hydrogen bond actually slightly came closer with each other. Therefore, the bond angle actually reduced, and the actual bond angle of water molecule is 104 degree. That is 104 degree. So though oxygen present 4 steric number, or water molecule, for water molecule it possesses tetrahedron structure, but the bond angle reduced to 104 degree due to this lone pair repulsion and 2 lone pair bond pair repulsion. Similarly, for H2S molecule, you know, here's the central atom is sulfur, similar like water, because sulfur and oxygen present in the same groups. So here also present 6 valence electron for sulfur atom, and again 2 valence electron of sulfur atom participate in the sigma bonding with hydrogen atom, and remain 2 lone pair produce 2 lone pair. That's why it also possesses steric number equal to 4 and the structure equal to tetrahedron, but due to this lone pair it show similar like structure like water, that is V shape. But you know, the bond angle of H2S and the bond angle of water is quite different. Why? Because this oxygen is electronegative atom, and due to this electronegativity, this oxygen atom attract electron from this oxygen hydrogen bond towards itself. But you know, sulfur is not such electronegative atom like oxygen, therefore it cannot attract this bonded electron towards itself. Therefore, for sulfur hydrogen bond, the electron density are slightly equally distributed between hydrogen and sulfur. But you know, sulfur is slightly better electronegative atom than hydrogen. But in case of water, the electron density more around this oxygen atom. Therefore, lone pair bond pair repulsion force actually slightly repels by this bond pair repulsion force, because here present more electron density, and due to this electron density, this lone pair bond pair repulsion force slightly repelled by this electron density. That's why the bond angle is 104 degree. But you know, in case of H2S, as sulfur is a non-electronegative atom, so the electron density are slightly apart from each other. Therefore, here the bond pair repulsion force is slightly lower than H2O. Therefore, this bond pair repulsion force, this bond pair repulsion force cannot repel this lone pair repulsion force. That's why this lone pair repulsion force are act as in higher intensity, and actually the bond angle reduced to more than 104, that is near about 94 degree. So for water it is 104 degree, and for H2S it is 94 degree. Next structure is PCl5, that is phosphorus pentachloride, and here the central atom equal to phosphorus, and you know, phosphorus belongs to group 15 element. That's why there present 5 valence electron into their valence shell. So this is the 5 valence electron for phosphorus atom, and this 5 valence electron participate in sigma bonding with 5 chlorine atom. So this 5 electron participate in sigma bonding with 5 chlorine atom. Therefore, total bond pair equal to 5, but here present no lone pair, so lone pair equal to 0. So total electron pair equal to 5. So the steric number equal to 5. And you know, for 5 steric number, the structure is trigonal bipyramid. So the actual structure of PCl5 looks like this, because this is a structure of trigonal bipyramid. Here phosphorus present as a center atom, and this 5 chlorine atom arranged itself so that the structure looks like trigonal bipyramid. That is the structure of trigonal bipyramid. And in case of trigonal bipyramid, there present two type of bond angle. This bond angle, the bond angle between the horizontal chlorine and this chlorine is near about 90 degree, and this bond angle equal to 120 degree. And as there present two bonds, two type of bonds, this two type of bonds named as two terms. So this bond actually known as axial bond, and this horizontal bonds actually known as equatorial bond. Equatorial bond. And the bond angle between two equatorial bond equal to near about 120 degree, and the bond angle between one axial and one equatorial bond is 90 degree. So this is the structure of PCl5. Next one is SF4, that is sulfur tetrafluoride. And you know, for sulfur the valence electron of sulfur is 6. So this is 6 valence electron of sulfur, and 4 fluorine atom participate in sigma bonding with 4 valence electron of sulfur atom. So this is the 4 sigma bond, and remain these 2 electron participate or act as a lone pair. So here present 4 bond pair and 1 lone pair. So total electron pair equal to 5. That's why the steric number equal to 5. And you know, for 5 steric number the structure is trigonal bipyramid. But the problem is here present 1 lone pair. So where this lone pair actually present? Is it in axial position or in equatorial position? So for SF4 there may be two type of structure possible. Maybe this lone pair present in axial position, or maybe this lone pair present in equatorial position. So what is the actual structure? Actually, you have to arrange this lone pair in such position so that the repulsion of lone pair and bond pair is much less. In case of axial, here present 3 equatorial bond, that is 90 degree apart from this lone pair. That's why there present 3 lone pair bond pair repulsion force. But in case of equatorial position, if this lone pair present in the equatorial position, then you know there present 120 degree angle between this lone pair and bond pair. Therefore their repulsion slightly less than this structure. So this actual structure is this. And always remember, if there present lone pair, then try to arrange this lone pair in such position where the repulsion is much less. And most of time this lone pair present in the equatorial position. So that is the actual structure, and this structure actually known as seesaw model. That is seesaw model because these two bond not actually present in 180 degree angle. Why? Because this lone pair repulsion force. So the actual structure looks like this. That is sulfur, and due to the lone pair bond pair repulsion force, so due to this lone pair and bond pair repulsion force, this two fluorine bond is not present in actually 180 degree because there present slightly repulsion. So the actual bond angle of this fluorine atom is less than 180 degree, and the structure looks like this. So it is known as seesaw model. So the structure of sulfur tetrafluoride or the shape of sulfur tetrafluoride equal to seesaw model. Similar for chlorine trifluoride, that is ClF3, and here this chlorine atom act as a central atom, and there present 7 electron into the valence shell. So this 7 electron, this is the 7 valence electron of chlorine atom, and 3 valence electron participate in sigma bonding with fluorine atom. So this is bond pair, and remain 4 electron present as lone pair. So there present 2 lone pair. So bond pair equal to 3 because this 3 bond participate in bonding. So bond pair equal to 3 and lone pair equal to 2. That's for steric number, or electron pair equal to 5. And for 5 steric number, the structure is trigonal bipyramid, and the actual structure looks like this. That is chlorine. So again, one question arises, that is where this lone pair actually present. So the answer is same. Lone pair, you have to arrange this lone pair in such position where the repulsion actually much less. So actually, if we arrange this lone pair into the equatorial position, then there present 120-degree angle between these two lone pair. So there the repulsion is very much less. Therefore, this lone pairs you have to arrange in, or you have to draw in equatorial position, and remain 3 fluorine atom present in this direction. So the structure of ClF3 is T shape. So the actual shape of ClF3 equal to T shape. So that's the structure of ClF3. Similarly, what is the structure of ICl2 minus? So actually this negative charge present on the central atom. So here the central atom is iodine, and for iodine the valence electron equal to 7. So this is 7 valence electron of iodine atom, and due to this negative charge you have to add 1 electron into the valence shell. So this electron actually write down due to this negative charge. So there present total 8 electron, and 2 electron participate in bonding due to this 2 chlorine atom in sigma bond, and remain electron act as a lone pair. So here present 1 lone pair, 2 lone pair, and 3 lone pair. So for ICl2 minus, bond pair equal to 2 and lone pair equal to 3. So electron pair equal to 5. So this is the steric number, and for steric number 5 the structure is trigonal bipyramid. So again you have to arrange, or you have to draw this lone pair into the equatorial position, so that the angle between the lone pair is 120 degree, and remain 2 chlorine atom present in axial position. So that is the structure of ICl2 minus, and this structure actually looks like I shape. So the structure of ICl2 minus is I shape. Next one is SF6, that is sulfur hexafluoride, and here the central atom is sulfur. So for sulfur there present 6 valence electron, and this 6 valence electron participate in sigma bonding with 6 fluorine atom. So their total sigma bond equal to 6. Therefore the bond pair equal to 6. No lone pair, that is lone pair equal to 0. So total electron pair equal to 6, and electron pair 6 means steric number equal to 6, and if steric number equal to 6, then the structure is octahedral, and the octahedral structure looks like this. That is the octahedral structure. So the structure of SF6 looks like sulfur present at center position, and 4 fluorine atom arranged in octahedron structure. So that is the structure of SF4, and again there present 2 type of bond. The horizontal bond, that actually this is a plane, this is a plane. Here present sulfur atom, 1 fluorine atom present here, and another fluorine atom present here. So that is the actual structure of SF4. So here that is the plane, and the planar or horizontal bond actually known as equatorial bond again, and this 2 bond known as axial bond. But the bond angle between this bond any type of bond is 90 degree, because the bond angle between axial and equatorial bond is 90 degree again, and the bond angle between two equatorial bond is 90 degree also. So there is a no difference in bond angle. So the bond angle of SF6 equal to 90 degree. That is the structure of SF6 or sulfur hexafluoride. Next structure is HCF4, that is xenon tetrafluoride. And you know xenon is a noble gas element, and xenon is the only noble gas element who can form a molecule with fluorine or oxygen atom. So in case of xenon, there present 8 valence electron. That is the 8 valence electron of xenon, and again there present 4 fluorine atom which form sigma bond with this 4 valence electron of xenon, and remain this 4 electron act as a lone pair. So they are present 2 lone pair. So bond pair equal to 4 and lone pair equal to 2. So total electron pair equal to 6. Therefore the steric number equal to 6, and you know for steric number equal to 6, the structure is octahedral. And as there present 2 lone pair, so you may draw this structure in such way, that is fluorine, fluorine, fluorine and fluorine, and 2 lone pair present in the axial position, and that is the structure of HCF4. And this structure actually known as square planar structure. Square planar structure. So this is the structure of HCF4. So this is the entire Vsepr theory, and by this Vsepr theory we may draw the structure of different chemical compound. But though this Vsepr theory have some drawbacks, and these drawbacks are some structure you cannot be draw or you cannot be assumed by this Vsepr theory, because for example HCF6, that is FC6, and according to Vsepr theory the structure looks like pentagonal bipyramid, but the actual structure is octahedral. So Vsepr theory cannot explain this fact, as well as this theory does not apply to many compounds of the transition metal and the system having extremely delocalized pi electron. So these are few drawbacks of this Vsepr theory. And the modified theory is VBT, that is valence bond theory. But I think today that is enough. Next day we discuss about VBT, that is valence bond theory, which is more modified than Vsepr theory. Okay.